Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from differentiability, right? And here we have to find the derivative of this function f of x, where f of x is mod of 2x minus 3 plus mod of 4 minus 5x, and then we have to find the value of the derivative at x is equal to minus 1, right? So we have to find f prime of minus 1. So let us start. So now here, before moving further, let us quickly revise the definition of mod function, right? So we know that mod of x is defined like this, that is mod of x is equal to plus x whenever x is greater than 0, right? So mod x takes the value positive value when x is greater than 0, and here mod of x is equal to 0 whenever x is equal to 0, and mod of x takes the value negative of x whenever x is less than 0, right? So here we shall use this definition to redefine this function f of x, right? So whenever we come across with these type of problems, our first objective is to redefine the function f of x, right? So for redefining this function f of x, we'll make use of this definition, right? So now here, let us first quickly see that this function f of x, which is mod of 2x minus 3 plus mod of 4 minus 5x, this function is not differentiable at these points, that is 2x minus 3 is equal to 0 and 4 minus 5x is equal to 0, right? So this function f of x is not differentiable at this point, which is given by this equation, that is 2x minus 3 is equal to 0 and 4 minus 5x is equal to 0, right? So when we solve these two equations, we'll get 2x is equal to 3 and x is equal to 3 by 2, and here we get 4 is equal to 5x and x is 4 over 5, right? So first of all, we conclude that f of x is not differentiable at these 2 points, right? That is x is equal to 3 by 2 and 4 by 5, right? Now we can say that f of x is differentiable in this interval, that is r minus excluding these 2 points, that is 3 by 2 and 4 by 5, right? And here we have to find the value of the derivative at x is equal to minus 1, right? So now let us draw a real number line here, and let us write here 0, 1, 2, 3 and so on, and let us represent these 2 points on this real number line, right? So 3 by 2 is 1.5, so it lies somewhere here. So this point is 3 by 2, right? And this point is 4 over 5, that is equal to 0.8, and this point 4 over 5, it lies somewhere here, right? So this is 4 over 5, and we have to find the value of the derivative at x is equal to minus 1, and here we have this point minus 1. So to redefine this function f of x, let us first take this term, that is mod of 2x minus 3, right? So by using this definition, mod of 2x minus 3 is equal to negative of 2x minus 3 whenever 2x minus 3 is less than 0, right? So here we have used this definition, right? So now if we solve this inequality, then we get 2x is less than 3 and x is less than 3 over 2, right? So now here we have to find f prime of minus 1. So minus 1 is less than 3 by 2, right? So here minus 1 is less than 3 by 2. That's why we have used mod of x is equal to negative of x whenever x is less than 0. And in this case, mod of 2x minus 3 is equal to negative of 2x minus 3, because 2x minus 3 is less than 0. And here we have x is equal to minus 1, right? And minus 1 is less than 3 by 2. So now this expression can be written as minus 2x plus 3, right? Now let us take mod of 4 minus 5x, right? So mod of 4 minus 5x is equal to positive 4 minus 5x whenever 4 minus 5x is greater than 0, right? So this inequality gives us 4 is greater than 5x. So x is less than 4 over 5, right? And here we have x is equal to negative of 1, and obviously negative of 1 is less than 4 over 5, right? So now this function f of x can be written as minus 2x plus 3, because mod of 2x minus 3 is equal to negative of here minus 2x plus 3, and mod of 4 minus 5x can be simply it can be written as 4 minus 5x, right? So now we have f of x is equal to minus 2x minus 5x is minus 7x, and here we have 3 plus 4 is equal to 7, right? So now f of x is equal to minus 7x plus 7, right? Now if we take the function as y is equal to f of x, then y can be written as negative of 7x plus 7, right? So now let us differentiate y with respect to x, right? So dy over dx, which is equal to f prime of x, is equal to d by dx of minus 7x plus 7. That is equal to minus 7 times 1, because the derivative of x is 1. And here we have 0, 7 being a constant. The derivative of 7 is 0. So here we have minus 7, right? So f prime of x is equal to minus 7, which is independent of x, right? So if we take x is equal to minus 1, then f prime of minus 1 is equal to negative of 7, right? So the derivative of this function f of x at x is equal to minus 1 is equal to minus 7.